Hey guys, it's Miss Gray here today to work with you through this particular problem, which is going to deal with the distance formula and understanding how to use that to find the distance between 2 points on a coordinate plane. Okay, so right here we've got 3 points on this coordinate plane. We've got point A, B, and C that represent places where player A, player B, and player C are. What's going to happen here? Player A is throwing the ball to player B. We want to find out how far that is. And then player B is going to throw the ball to player C, and we want to find out how far that is. Okay, how we're going to have to do that is we're going to use what's called, and you've seen this before, we're going to use what's called the distance formula. Here it is. Okay, the distance between any 2 points on a coordinate plane can be found by taking the difference of the x coordinates, squaring it, and then adding that to the difference of the y coordinates after you square that, and then we're going to take the square root of that whole thing. Okay, so if we go back here, the first question says, how far did player A throw the ball? Okay, so player A throws the ball from point A to point B, or she or he throws it to player B. So the 2 coordinates we're going to deal with for part A here are the 8, 4, okay, because that's where player A is, and then the 18, 7, because that's where player B is. Now the formula, and I'll write it right here. Okay, we've got x sub 2 minus x sub 1, square it, add that to y sub 2 minus y sub 1, square it. Okay. Now, in these 2 sets of ordered pairs, let's go ahead and let's identify what x sub 1 and x sub 2 are going to be and y sub 1 and y sub 2 are going to be. Let's call the 8 the x sub 1, so that makes 4y sub 1. And then the 18's x sub 2, that means the 7 is y sub 2. Okay, so let's go ahead and let's throw all this into our formula here. Okay, so the square root, the distance, I should have said, of between those 2 points is the square root of, and let's go ahead and let's plug stuff in. Okay, that's going to be 18 minus 8, and we're going to have to square that, plus 7 minus 4, and we're going to have to square that. Okay, so as we simplify this, okay, 18 minus 8 is 10, so we've got 10 squared there, and then 7 minus 4 is 3. It's going to be 3 squared. 10 squared is 100. 3 squared is 9. So here I've got the square root of 109. Now, that radical doesn't reduce, okay, but we can get a decimal equivalent, and the decimal equivalent to that, the square root of 109, is, if round to the nearest tenth, it's 10.4, and our units here are dealing in are meters. We're dealing in meters. So that's how far it goes, or it takes the ball travel from player A to player B. Now the second question, it says how far does player B throw the ball? Okay, so with player B is throwing to player C. So the coordinates we're going to deal with here are again the 18, 7, but this time she or he's throwing to player C, so the 24, 14. So let's go ahead and again, let's label what our different coordinates are going to represent here. So the 18 this time is going to be x sub 1. The 7's y sub 1. The 24 is x sub 2. And the 14 is y sub 2. Now, does the point on the left always have to be the first point with the sub 1s like you see right here? Okay. And here? No. Okay, it very well could flip-flop, okay, these two with these two. Okay? All right? You could do that. It doesn't matter. You can choose either one. But let's go ahead and let's just stick with what we got. Okay, so over here, the distance then between player B and player C, as we plug stuff in here, this is going to be 24 minus 18, difference in our x coordinates. We're going to square that. And then y sub 2 minus y sub 1 is 14 minus 7. And we'll go ahead and we'll square that. 24 minus 18 is 6. 14 minus 7 is 7. 6 squared is 36. 7 squared is 49. 36 plus 49 gives us 85. Square root of 85. Now, that radical does not reduce, but we can make the decimal equivalent. And if we round to the nearest tenth, it's about 9.2 meters. Okay, so player B throws the ball 9.2 meters to player C. So that takes care of part A. How far did player A throw the ball? Okay, right here we figured it out with what you see in blue, 10.4 meters. How far did player B throw the ball? We figured it out right here in green, 9.2 meters. So that takes us then to part B. Okay, and part B is asking us if player A would have to throw the ball directly to player C, how far is it going to be? So if we look at our figure up here, okay, so for player A to throw it to player C directly, now we're talking about a straight line just like this, okay? And we want to figure out how far that is, okay? So again, we can go ahead and we could use the distance formula here, all right, to figure it out. The ordered pairs we're dealing with now, okay, point A is 8, 4. And this time point C is at 24, 14. Okay. All right, again, let's go ahead and label. All right, we go x sub 1, y sub 1, x sub 2, y sub 2. And we throw it in to the distance formula. We're going to have 24 minus 8, square it. And then we're going to add that to 14 minus 4, square it. 24 minus 8 is 16. 14 minus 4 is 10. 16 squared is 256. 10 squared is 100. So that'd be the square root of 356. Now, this time, the square root of 356, that does reduce a little bit. Okay, that does reduce a little bit. And so the simplified version of the radical is 2 times the square root of 89. And then the decimal equivalent is 18.9 meters. So for player A to throw it directly to player C, it's about 18.9 meters.